So we can get started. Okay, we got 3 seconds left for test 2. I'll knock out 6-1 today and start 6-8. Then the next half we'll finish 6-8, and then we got a little section time 4. So 2 to 3 sections are fairly small. Okay. All right, so this will be 6-1, and it deals with radical expressions. And really on this, what you're going to do is play with a domain problem, and then it has problems with a graphing them. And on the graphing in this section, it's just pick a picture. So they'll give you 4 pictures, and you'll just pick the one that's got your moves on it, okay? So first of all, we'll look at a domain of a radical. And radicals look like this. So you have a function. With that radical, okay? So when you find a domain, you want it to be real numbers, outputs that you're getting out of them radicals. So when we look at the domain of a radical, we got to worry about what's under that radical being positive. And it can actually be 0, but you don't want it to be negative under that radical. If it's negative, then you'll get imaginary numbers, okay? So first thing I'll do on these is I take what's under that radical, which is the x, and I set what's under the radical greater than or equal to 0. Then you're going to solve it. Solve for the variable. And it looks like on this they're using set builder notation. So right answer in set builder notation. Now, when y'all did set builder, they usually gave y'all A, B, C, D. You just pick the one with the answer. But set builder notation was the one where they did the curly parentheses, and they put the x such that x is real number, and x has to be greater than or equal to whatever answer we get on these, okay? And that's the thing on these, since we're messing with inequalities, you can have more than one answer on these, okay? Oh, and then I guess this will have a little curly parenthesis there. And then we'll sort of look at the graphs of these, okay? So there's only going to be one done domain for y'all. And then looks like 5 of these are going to be graphs. So this one, they want to determine the domain. All right, so they're giving me f of x is equal to the square root of 4x minus 7. So my domain's got to be x's, so that when I push these x values into that equation, I get square roots of real numbers and not imaginary. So So here I'm just gonna follow my steps. First thing was to set what's under that radical greater than or equal to 0. So I'm gonna set 4x minus 7 greater than or equal to 0. All right, now we're just gonna solve that for the x. So looks like I'm going to what, add my 7 and then divide by the 4. So let me add 7. So that the 4x has to be greater than or equal to 7. And then I'll divide by 4. So that cancels. So I get an x greater than or equal to 7/4. Now y'all, just be careful when you're doing this part where you're solving it. If your x is negative and you divide by a negative number to get that variable to be positive, you got to reverse the little inequality around it, okay? And I'll do one just doing that so y'all see what I'm talking about. So this answer would actually be x such that x is a real number and x has to be greater than or equal to my 7/4. Be careful on these answers because they'll have greater than or equal, less than or equal, not equal, and they'll use different symbols on those, okay? So I'll show y'all one where you might have to, so this would be like a 1B. Let me have f of x is equal to square root of something like 7 minus x. Well, some of y'all might get negative x's and some of y'all might have that question like my very first one, okay? So what we're going to do is take the 7 minus x, set it greater than or equal to your 0. All right, now we're going to solve that. So I'm going to start out probably by subtracting a 7. So that brings down to negative x greater than or equal to a negative 7. So this is what I was talking about a while ago. Now I got a negative 1x sitting there. To make that positive, I got to divide both sides by negative 1. But this is the point, y'all. Since I'm dividing by a negative number, I've got to reverse the inequality. So inequality will now be less than or equal. So my final answer, x has to be less than or equal to a positive 7. So that makes sense. When I put a 7 in there, I get a 0. But if I put an 8 in here, 7 minus 8 would give me a negative 1. So that's why this is telling me, hey, you can't use no x is bigger than 7. I can use negative numbers because remember, 2 negatives make that a positive, so you actually be getting a big positive number under there. So here we go. We would have our x such that x is a real number and x has to be less than or equal to that 7. Okay, so that was the second thing we was worried about on domains. We did the fractions of, those were what, chapter 2 or so. We did the fractions and set them equal to 0. Radicals have to be set greater than or equal to 0. Okay? All right, then they want us to start to graph some of these. All right, so I'll graph f of x equals 5 times square root of x. So when they put a number in front of a radical, so numbers in front of the radical, this is a move they didn't give us in when we was moving the graphs around. Numbers in front of the radical. If this number, I'll call A, is greater than 1, then it's going to stretch. Then it's going to stretch the graph. So what that means is it's multiplying all the answers by 5. So if your answer was 1, multiply by 5, it stretches from 1 up to a 5. So numbers in front stretch it, but if the A is less than 1, such as a fraction, so how about this? How about the absolute value of A? We'll do it like that. So if the absolute value of the A is less than 1, then it's going to sort of shrink it down. So if it's a fraction in front, it's going to shrink it down. But you'll be able to tell by what moves you already know about which graphs to pick on this, okay? So I got a graph here. I'm going to draw 4 graphs real quick. Oh, and this one sort of looks normal. This one went under and up. Okay, then let's see. That went down and under. But if you remember your basic graphs on these, this one would be the basic graph. That's when we drew the picture and then we just made a nice, slow uphill. We've never seen a radical do that, right? Go under. The only way to get this one was if they do a negative in front. Remember, the negatives reflect them. So the only way to get this one is if they do a negative in front of that problem. So the only one that looks like they stretched it actually would be my first one. They took the normal graph and it sort of stretched up by a factor of 5 when they do that 5 in the front. So I would go with, that's from out, okay? So I'm going to do one more graph and then move on. How about f of x equals square root of x minus 2? It looks like a straight line. B is over here and going. C looks like it reversed. And then D is something way down there. So what you want to think about, what's that minus 2 doing to my graph? So you treat this like it was in parentheses. And instead of 2, when we attacked those x's in parentheses, we went left and right. If I added 2, it actually went left, and if I subtracted 2, it's actually going to go right. Oh, I drew the wrong picture, John. Let me draw one more. This one should be like this, actually. Okay. Do another problem answer. But that -2 makes my graph actually move to the right. So remember, they should normally start in the center. So it looks like that's a straight line. There's no way it can be that one. This one looks like it moved left from here, left 2. This one moved right 2, but look what happened. It's in the opposite direction. And we haven't done moves that reflect me on the Y yet. But look at this one. Little parabola looks like it moved over 2 units. So on these, you're just going to pick one of them graphs and be done. Or what? Graph them on in calculators, and you'll see which one exactly that's going to show you, okay? So I guess the main thing, we just wanted to expose y'all to that domain problem, okay? So I don't know why they only want 1 domain and 5 graphs, but let's move into funner stuff. Y'all ever heard of a piecewise function? Oh, no. 6.8, my bad. Just keep around so much in here. 6.8 deals with increasing, decreasing, and piecewise functions. So it's going to start with the piecewise functions. So I'm playing the piecewise function, and I say y'all actually know what these are. You live them if you work. You ever work overtime? So you agree that you use one equation if you work up to 40 hours, but if you work overtime, don't you got to use another equation to figure out that time and a half pay and all that? So that's a piecewise function. Depending on your hours, depends on which equation you use, okay? So this usually is a system of equations that can be used to model a situation in which the value of the x determines which equation we use. Okay, so the value of my x determines which of these equations I'm going to use. So in the beginning of this section, they give you a piecewise function, and they just want to know which equation would we use determined by the x's they're giving us. So, given f of x is going to equal, I'm going to have 3 equations, okay? It's going to equal x squared for any x that is less than -5. So if it's a -6, -7, something smaller than that -5, I'm going to use the x squared equation, okay? It it'll equal 3x for -5 less than or equal to my x less than 3. So if it equals -5, but it's still less than a +3, I'll use the second equation and put whatever number in for the x and multiply by 3. The last equation will be x minus 4 for any x greater than or equal to 3. So all possible numbers are now represented. Anything less than -5, use the first equation. From -5, still less than 3, use the second equation. And then for any x that's 3 or bigger, use my third equation. So which equation would we use to find f of a -15? So if my x was -15, would I use the top equation, middle equation, or the bottom equation?
The top one.
The top one, because -15 is definitely less than a -5, right?
Mm-hmm.
So we would use the equation that says f of x equals x squared. Okay, so first few just doing this. At the very end, they'll actually have us evaluate these. All right, so we'll try one more of those. All right, so given, this time it still has 3 equations. F of x equals all right, it's going to be x squared for any x less than -2. It's going to be x minus 4 for -2 less than or equal to x less than 1. And it's going to equal 8x for any x greater than or equal to 1. So which equation would I use to find f of 1? All right, so for 1 f of 1, which equation? Top, middle, or bottom? Bottom. Good job, because it's got the equals 1 in here. So you definitely use the bottom one. So that would be what the f of x equals 8x. Okay. And it's all you do to these. You find your x value. Which domain is it going to fit into? And once you got that domain it fits into, grab that equation, okay? Okay, so here's what's sort of wild. The other last week, I did problems and y'all had to worry about increasing and decreasing. This section officially breaks them out, okay? So it's sort of weird, we're a little bit out of sync on that homework. So increasing and decreasing in constant intervals. So to be increasing, that graph has to go uphill, left to right. Which means all of my y values are actually increasing. So you're looking at what's happening to the y values on these. So my y values are actually increasing. Decreasing will go downhill left to right. Which means increasing has a positive slope, decreasing will have a negative slope. It's going to go downhill. And then what about constant? Y'all heard of constant? It sort of means it stays the same. So it's basically going to be a horizontal line left to right. Right? Because what that horizontal means is that my y values are not changing, although my x's are, okay? All right, y'all, so we're going to use interval notation. So we use interval notation for intervals of increasing, decreasing, and constant. Okay, so I'll use my interval notation.
It's cold in here.
Oh, it is like 69. What you want on 71?
It don't matter.
Check it up a degree. Oh, I don't know if it works. I was told once that they were just there for show. This building is like controlled automatically down there. They got like a control room or something like that. So. All right, so I'm gonna draw a function here. So let me try to draw this. So it looks like this goes 1, 2, 3, 4, 5. And then about the same going up. All right, so right here at 3, -2, I got a point. And then at -3, -2, I got a point. So 3, -2, and -3, -2. All right, so they're going to want me to find my increasing, decreasing, and constant intervals. So I'll start with increasing. So when you're doing these intervals, we only want the x values on the interval. Where at on these x's is this thing increasing is basically what they want to know. So it looks like it starts increasing right here and going uphill. So I need to know what that x value is where it starts increasing. Well, it starts increasing at the x value of a +3. Now, these will always use curvy parentheses on those because those points can't be both. So they just say use them with curves, okay? So I'm on the x-axis at 3. My graph starts going uphill as I head towards infinity. And in infinity always has a curve, okay? So from 3 to infinity on my x-axis, my y values are increasing. decreasing is this part of my graph going downhill. But remember, I still need to worry about my x's, so that looks like it's hitting about right here. So it looks like at this point right here, it's going to stop decreasing and then starts going straight across. So I need that x value where it stops. Where it stops is going to be what? A -3. So where's my graph starting from? Way out here. As it comes in, it's decreasing until it hits -3. So we say this graph is coming in from a negative infinity. Okay. And then the last one would be the constant section. Constant is my flat part of my graph, or it looks like a horizontal line. So it starts going horizontal over here at x value of -3. And it stays horizontal until I get to this x value of a +3. So if you notice, these increasing and decreasing in constant intervals are basically the domain values. Okay. So y'all good on that? All right, this next one will be a fun one to draw. I'm gonna try to get it done though. All right, let's see. This going on about 6. -6. All righty, so let me see how this is going to be. So up here at 2, -1 and 2 right here. I got a point at -1, 2, and from here on, it just goes straight across. Right over here at -3, -2. This is going to go straight up like that. So y'all, this point here was -1, 2. This point here is -3, -2. All right, then over here at -5, 1. So this point would be -5, 1. This thing sort of curves from here to there, and then from here it goes down. Ooh, those are hard to draw sometimes. Main thing is catching the points I've got. We don't really care where it's crossing those axes is at. We just want you to change over points. So once again, I'll do increasing, decreasing, and constant. I notice now don't be fooled. They got an arrow going this way, but we still going to read this graph left to right. This part's going uphill, downhill, uphill, and then constant, okay? You got to read it left and right. So I want to know where I'm increasing. So I'm going to first take this little part that's increasing. And I know that changeover point is at that -5, okay? So this graph is coming in from -infinity. As I'm cruising these X's and I hit -5, it stops going uphill. So this one stops at -5. But notice, you've got this section right here going uphill also. This one right here goes uphill. So when you got more than one section going uphill, you got to use our union. The union means and. And then let's look at this second piece that's going uphill. We need to see what X this starts at and where it stops. So it starts going uphill again at -3 on the X's. And it's going uphill until it hits this X right here, which is -1. So from -infinity to -5, I'm going uphill. And then when I hit -3 to -1, I'm going uphill, okay? And that's the only two parts going uphill, left to right. Decreasing would be the part going downhill, left to right. So y'all, it looks like I've only got one part going downhill. And that's the right half of that upside down looking parabola there. It starts going downhill at the X value of -5. And as I go down the X's, I'm going downhill until I get to this point, which is at -3. You'll notice when I get done, all these points will go from each other. Right, see, I go from -infinity to -5, -5, -3, -3, -1, which means this interval must start at that -1 right here, being constant on the X value of -1. And then this one is constant from -1 to infinity. Okay, so when you're done, your interval will go from -infinity to positive infinity to there, okay? Those aren't too bad, it's just keeping up with the intervals, and remember, we're only looking at the X values on these, okay? Only time I'll ever have y'all use Y values is on the range. All right, here we go. Relative max. They call them maxima. And then we'll have what they call relative minimums. They're only looking at sections of the graph. Like this one, this little hump right here, this would have what we call a relative maximum, because relative to this little section, that'd be the maximum point. Okay? And that's all these are. These are the maximum values. From sections of the graph. That have peaks. Okay, so I might have 3 relative maximums in the graph, but I might have 3 little peaks in there, okay? But that's all they're looking to is it's relative to these sections, okay? Which means our relative minima will be the minimum values from sections of the graph. That have what I call valleys. All right, I'll show you how they do on these ones, okay? I'm gonna draw one more picture. Now, at least this chapter don't really have a lot of graphs. Y'all got to do by hand on the math lab, okay? Just pictures usually. All righty, so over here at -1, I got me a point. And then over here at -3, 2, I'll have a point. So let me see how this is going to come down. We'll get this one. This one shoots up. And then this one just shoots down. So they got me a relative maximum is blank at x equals blank. Relative minimum is blank at x equals blank. So the min or max values are the y values, and then they happen at whatever those x values are. So the relative maximum, we're looking at this one because this is my peak. So I want to see what is that maximum value and then what x did it happen at. So remember, we said this was what? -3, 2 here. Which means the maximum value or the y value would be 2 at that point. And it got that value of 2 at the x value of, what's that, -3. Okay. These aren't bad, y'all. They're just figuring out what they want us to put up here. So my relative minimum. And remember, I said this point was -1, -1. Which means that has a relative minimum of -1, which is the y value. And it happened that the x value also equals what? A -1. Okay. All right, so that's not too bad. So I'll close it with one last problem. That way y'all can have enough to get through it all if you want to tonight, okay? All right, given g of x equals x plus a for x less than or equal to 1. It's going to equal 7 minus x for x greater than that 1. They want me to find 3 things. They want me to find g of -3, g of 1, and g of 5. So for each one of these, you got to figure out what your x value is going into the equation. Which equation would I use based on that x value? Plug that x in and get me the answer. So for g of -3, would y'all use the top equation or the bottom? So let me ask y'all this. Is -3 less than or equal to 1? So definitely less than, right? So we're going to use this equation, x plus 8, since my x is less than 1, okay? So what that means is I'll put my -3 in for the x, and then add A. Okay? So basically, -3 plus 8 is the same as 8 minus 3, which gives me what, a 5? So G of -3 equals 5. Then they said, hey, find me G of 1. So G of 1 is the crossover point between the two equations, but one of those has to equal to it. Which means I once again will use the x plus 8, right? Because 1 is equal to 1. So that means put a 1 in for my x and then add 8. Okay? So G of 1 will give me a 9. And then finally, they wanted y'all to find G of 5. Well, this time, 5 is not less than or equal to 1. So I'm going to go to the second equation and see 5 is greater than 1 does make that one true. So this time I need to use the 7 minus x. So that'll be 7 minus my x, which is 5. So G of 5 is 2. So that'd be sort of what they would do with y'all. Up to 40 hours, you're going to get 10 times whatever your x's is. Anything over 40 hours, you're going to get 400 plus time and a half your total hours minus the 40 hours. Okay, so if you work 47 hours, 7 of it would be at the time and a half pay. Okay, so this does not be bad. It's just a lot of different topics y'all are going to go to. All right, questions on those? So remember that 6-1 will be really short. It's just got one problem, you find the domain, and then the rest of them you're just looking at graphs. Okay. All righty, only one online today. Oh no, I got a few more. Taylor and Nick Martinez. All righty, so I'll get this video sent out for y'all.